Assalamualaikum dear students. In previous lecture we discussed logarithmic and exponential functions, and you know that the differentiation of e of x is e of x, that is exponential function is e of x, and differentiation of log x is 1 upon x. Now today we are going to discuss exercise 5.4, and this exercise wholly and solely depends upon these two concepts, that is differentiation of this e of x is e of x and differentiation of log of x is 1 upon x. Now we are going to solve the questions from this exercise 5.4 which depends upon these two things, that is differentiation is of these two functions is this and this, and on chain rule. Now the first here function is e of x upon sine of x. Let y equals to e of x upon sine of x. Here we are going to find its derivative, that is we are going to find it as dy by dx. If we denote this function by f of x, then we have to find f dash of x. Here by differentiating on both sides and using the quotient rule of differentiation, because here y is the quotient of two functions e of x upon sine of x. You know that the quotient rule of differentiation is dy by dx is denominator, that is sin x, differentiation of numerator e of x minus e of x into differentiation of denominator, that is sin of x, upon denominator square. Differentiation of e of x is e of x and differentiation of sin is cos. So taking ex common, it is ex into sin x minus cos x upon sin square x. Now this is a function, it should be defined in a given domain. So the given domain becomes x not equals to n pi, because if x equals to n pi, this denominator vanishes. When denominator vanishes, function is not defined. So this means that this dy by dx is valid for all points except x not equals to n pi. Similarly, if we have function e raised to power sine inverse x, here we are going to use the chain rule of differentiation, because this function e raised to power sine inverse x, it is composition of two functions, one e raised to power x, second one sine inverse x. So using this, by differentiating, it is dy by dx. Now chain rule means we have to firstly differentiate this e, that is exponential function, and differentiation of exponential function is the given exponential function, it is e raised to power sine inverse x. Then we have to differentiate this power is here sine inverse x. You know that a differentiation of sine inverse is 1 upon root 1 minus x square. So the given differential becomes e raised to power sine inverse x upon root 1 minus x square. But this is the function, this differential is again a function, it should be defined. So it is defined only when x belongs to open interval minus 1 1, because if we put x equals to 1 or minus 1, denominator is 0, so function is not defined. Similarly, if we put points which are greater than minus 1, which are less than minus 1 and which are greater than 1, again here this is this denominator becomes root of negative number. You know that in real, root of negative is not defined. So this means that the given differential, or the given is the function, given this is the differential which is defined only when x belongs to minus 1 1, or this differential is valid only in this interval. Now the third one is sine of tan inverse e raised to power minus x. Here this function is the composition of 3 or 4 functions. So using differentiation, this chain rule, and differentiating this y equals to sine of tan inverse of e raised to power minus x, firstly differentiate sine, then differentiate tan inverse, then differentiate e raised to power minus x, and in last we have to differentiate minus x. So after differentiating all these functions, we simply get differentiation of this function is minus e raised to power minus x cos tan inverse of e raised to power minus x upon 1 plus e raised to power minus 2x. Here this denominator 1 plus e raised to power minus 2x, because you know that the exponential function has no 0 in R. So this means that in particular this function e raised to power minus 2x is not equals to 0. Also it is always positive, so this means that positive plus positive is always greater than 0. Hence 1 plus e raised to power minus 2x is not equals to 0 for any x belongs to R. Hence this derivative, that is dy by dx, is valid for each and every point of R. So this means that it is a required derivative of a given function. Now another one is we have to differentiate log of cos e raised to power x. Here it is the composition of three functions. First log cos of x and e raised to power x. Now if we put y equals to log cos e raised to power x, so by using chain rule and differentiating this function, it is dy by dx. You know that the differentiation of log x is 1 upon x. So here x is cos e raised to power x, that is 1 upon cos e raised to power x. Then we have to differentiate cos e raised to power x. Differentiation of cos is minus sign, angle is here e raised to power x, that is minus sign e of x. Then we have to differentiate this angle, which is d by dx of e of x. D by dx of e of x is simply e of x. It is simply minus sign e of x upon cos e of x, that is minus e of x tan e raised to power x. So this is the required differential, or derivative for the given function. Another one is y equals to e raised to power x square up to e raised to power x raised to power 5. Let y equals to this, which implies that by differentiating and using the algebra of differentials, that the differential of sum equals to sum of differentials, that is derivative of this function is actually differentiation of e of x plus d by dx of ex square plus so on to d by dx of e raised to power x 5. Differentiation of x square x e raised to power x is simply e of x. Differentiation of e raised to power x square is e raised to power x square. Then we have to differentiate x square. You know that differentiation of x square is 2x. Similarly, up to this e raised to power x5, its differentiation is e raised to power x5 into, then we have to differentiate this power. It is x5, which is 5x raised to power 4, because differentiation of x raised to power 5 is 5x raised to power 4. Hence, its derivative is this e raised to power x plus 2x e raised to power x square plus so on to 5x e raised to power x raised x5, that is x5 x4 into e raised to power x raised to power 5. You know that this root is defined for only positive numbers, so this means that if function is y equals to root of e raised to power root x, this x should be greater than 0. Here we have to find the differential of this, that is derivative of this function. If y equals to root e raised to power root x, which implies that y square is taking squares on both sides, it is y square equals to e raised to power root x. So given function is simply this y square equals to e raised to power root x. Now differentiating with respect to x, it is differentiation of y square is 2y dy by dx, and differentiation of root x is e raised to power root x into d by dx of root x, which is 2y dy by dx e raised to power root x. Now differentiation of root x is 1 upon 2 root x, because by using x raised to power n rule, here n is 1 upon 2, because root means power is, or index is 1 upon 2, which is simply 2y dy by dx is e raised to power root x into 2 root x, or simply dy by dx is e raised to power root x upon 2y is here in multiplication. When we transfer to other side, it becomes the denominator, that is 4y root x, because 2 into 2 is 4. So simply e raised to power root x upon 4 root x into root e raised to power root x. So this is the required differential or derivative of this given function. Find the derivative of log x. So it is the composition of two functions, log and log. So differentiating and using chain rule, it's dy by dx is log of, now differentiation of first log is 1 upon this, it is 1 upon log of x. Then we have to differentiate this log, it is d by dx of log x. Differentiation of this log is 1 upon x, so it is simply 1 upon x log x, which implies that derivative is 1 upon x log x, provided this x is non-zero, provided this x is not equals to 0. Non-negative, sorry, provide x is non-negative, because log is not defined for the negative numbers, log is not defined for 0. Now the last one is cos of log x plus e raised to power x.
Now differentiating this, firstly we have to differentiate this cos. It is minus sign of this angle, that is log x plus e of x. Then we have to differentiate the angle. Here angle is actually sum of two functions, one log x, second one e of x. So it is d by dx of log x plus e of x, which is simply differentiation of log is 1 upon x and differentiation of e of x is e of x. So it is 1 upon x plus e of x, which is simply, after solving, minus 1 plus x ex upon x into sine log x plus e of x. So in this way you can solve, you can find the differential of any function containing, the logarithmic or exponential functions as a part. So inshallah in tomorrow's video lecture we will discuss, the logarithmic differentiation, that is how to differentiate, the function raised to power function. So thank you.